All right, so here we're on 12.2 on integration by substitution. So what we're going to do is we're going to learn about reversing the chain rule, integration by substitution, and additional substitution techniques, and then we're going to do some applications. So with reversing the chain rule, recall the chain rule is the derivative is going to be, you have f of g of x. Well, you're going to take the derivative of g of x out here and then take the derivative of f of because with the g inside. So you know what I'm talking about when you do that. Written, it's what it looks like here. So now the expression on the right is formed from the expression on the left by basically taking the derivative of the exterior function of f and then multiplying it by the derivative of the interior function of g. Now, if we recognize an integrand as the chain rule form, e prime, or the first derivative, I of x, and then I prime, again, derivative of I of x, we can easily find the antiderivative and its indefinite integral. So this is what we're going to start with. And what we want to go to is we want to take the integral or the antiderivative and get to this part here. So what we're really interested in is finding the indefinite integral. So something that looks like this we start with, and when we get done, we want to come up with, and it's going to look like something like this. And how do we do that? Well, what we're going to have to do is we have to think about what's inside pieces and the outside pieces, and then go from there and do substitution. So the integrand appears to be the chain rule form e to the gx times g prime of x for this one, which is the derivative of e to the gx. Since if we take the derivative of this, we get this. Okay, so that follows then if we take this antiderivative, we should get here. And so what we have to do is we have to think about, okay, if we took this derivative, we're going to get 3x squared, and that's what we get here. And then if we have the derivative of e of x, that's going to be e of x. So that's what we get. All right, so let's look over here. All right, so now how does the following indefinite integral differ from the 1 and 2? Now remember, the 2 was this one. And if you notice, the key difference is this factor of 3. So this factor is within a constant factor of being the same derivative of e to the x cubed minus 1. But because that constant factor is moved across the integral sign, this causes us a little trouble finding the actual indefinite integral of the x squared e to the x cubed minus 1. So what we have to do is we have to introduce this constant factor 3 and at the same time multiply it by 1/3 and move that 1/3 outside the integral sign. So this is basically the equivalent of multiplying the integral by 1. Okay, so what we want to do is, so we start with this. So we're going to multiply this by 3 so that it looks the same as this. But then we also have to bring that 1/3 out in front. And so we're going to have 1/3 of whatever this is. And so basically now we have 1/3 of this instead of what we had down here, which was e to the x cubed minus 1. So because we didn't have that third there, we have to multiply by the 3, and I think this is probably the better place to look. Multiply by 3, but to get that, we had to bring a 1/3 out here, so we're really multiplying only by a 1. And then we get the 1/3 e to the x to the third minus 1 all plus c. Okay, so now what we can do is we already know how to figure out this integral. And so when we have missing variable or missing variable x, this is actually more serious. If we have just a missing factor 3, maybe we have a half or something like that, that's easy to fix and we can do that. And so that's what we're going to see later. So remember, you can't pull out variables out in front of the integral signs. So that's the key difference here. Is we can do constants, but not variables. All right, so some general indefinite integral formulas. So if we have f of x to the n times the derivative of f of x dx, then that's going to give us f of x to the n plus 1 over n plus 1 plus c. And again, n cannot be equal to a -1 because we can't divide by the 0. Then we have e to the f of x times f prime of x dx. That's going to give us e f of x plus c. And if we have 1 over f of x times f prime of x dx, then that's going to be the ln of that f of x absolute value, and then plus c. All right, so I think a lot of this is not going to make sense until we actually get into the nuts and bolts of doing it by hand. And so what we're going to do is we're going to start off by saying, okay, well, let's find each indefinite integral. All right, so what do we have? Well, if we're doing our normal thing, if we look at this first one, and if it lets me right here, nope. What we have is this is kind of like our I of x, and this is our I prime of x. Okay, that's the inside function. That's the derivative of the inside function. And so then what we can do, it's going to be something like this. That's the inside function to some value n, then the derivative. And that's what we've done. We've taken the derivative of this, and that's what that is. And so what we can say then for a is, well, that inside piece is going to be a 2x to the third minus 3. We're going to raise this up 1, so it's going to be over up to the 21. And we're going to divide it by 21 and then plus c. And so that fits this one here. We're taking our inside function to the n plus 1 divided by n plus 1 plus c. And so that's what we've done for a. Now b, what about it? Well, now our inside function kind of is this 5x. Well, if it's going to let me write it here, that's kind of our I of x. This is our I prime of x. And so this relates to this function. Okay, so that's our f of x, that's our f prime of x, or I, or however you want to look at it. And now it's just going to be e to the f of x plus c. So b, where's my pen? There it is going to be just e to the 5x plus c. Okay. Now on c, well, here we have 1 over this. So this kind of is our, again, now they're using f of x, so let's use f of x this time, and this is f prime of x. Well, remember, that's just going to be the natural log of the absolute value of what's the inside function, which is the 4 plus x squared, and then plus c. Okay, and so this is how we can find these indefinite integrals using these general indefinite integral formulas. So it fits nicely with these, and we can do that for this a, b, and c here. So let's pause and we'll come back for more.